last class we studied two activities and we learned what is induced current and what is EMI, electromagnetic induction. And today we'll continue that part. See, first let us start solving with one MCQ question. Look at the question. If a south pole is approaching a coil, then the direction of the current at the coil end is what? We need to find out direction of current. Here simply I gave two options. In the exam they will add two more options. See, as I told in the last class, from this magnetic effect, this is the only topic where they will ask indirect and twisted questions. So we should be prepared for all the types of questions, right? Because we don't want to lose marks. We should take 1 mark also from this part of a chapter. See, listen carefully. To solve, first try to answer yourself which one will be correct. If not, let us go for two more techniques. We will understand what are those techniques to solve this question. And I am saying that, see, those techniques will act as a tricks to solve this question. So no need to by-heart that and no need to just understand how that will help in this one. Okay. So those techniques, one is what? Clock rule. Another one is Lenz's law. Both are not in a syllabus. So just understand to solve these type of question. Okay. I hope you are understanding what I am telling. Those two techniques will help us only to solve these types of questions, since we are aiming at to not lose any marks in this chapter, particularly under this topic. Okay, so let us see what are those two techniques. As Hans Onsted told that in an electric carrying conductor, if the current is passed, then magnetic field will produce. We know that in the beginning of this chapter. If the magnetic field is produced, we know that there will have one north pole and will have one south pole. If we have one north pole and one south pole, we need to know the direction of current. To know the direction of current, this clock rule will be very important. This is something which is out of syllabus. This is a tricky concept. You can easily answer MCQ or 1 marks type questions. So let us see what is clock rule. So observe here the clock rule, that is we have one north pole and one south pole. So we just look at this diagram, both are same. In the north pole, let us written the north in such a way that the current will be flowing in this way. See, this is not in the syllabus, it's just a trick. You no need to write in the notes also. If you want to remember, write somewhere or write it as an extra information, but no need to buy it, just for understanding purpose. Now see, if this is n direction, take this as a starting material and observe in this way. If a magnetic field produced, then this is our north pole, hence the current will be flowing in anti-clockwise direction. Okay, as we wrote n like this, tip of this one will go like this and another one will go like this. If we produce in such a way, that means anti-clockwise, right? And what happens in the south pole? I wrote S like this, which is the continuation like this, and this is nothing but what? Showing the direction, right? That is in the clockwise. So understood, and it is very easy that if they ask you the question what is the direction of current while giving some poles, it is very much important. See, if this is north pole, hence the current is flowing in anti-clockwise. And what is this outer circular? Same thing, I just wrote the conductor, that is in the north. If this is a coil, if this is our north, we have some conductor in circular way, right? So I just wrote this one. It's the same thing. It's anti-clockwise. The current is also flowing in anti-clockwise. And same thing, if it's south, the current is flowing in clockwise direction. This is nothing to by head. Just keep in mind, if north pole, then the current will be in anti-clockwise. If it's a south pole, then the current is in clockwise. And what what is the trick? That is, south means you will just write the S and tip of this S will continue like this, and if not, it will like upwards. This is the way, that is anti-clockwise. And this is, we can prove this trick really works, and this we can prove with an activity or experiment also, by knowing but one end and another end, that no need to understand. Just remember this one. And one more thing, what is this called as? Clock rule. Clock rule, from this what we can detect the direction of the flow of current. But this is not only enough, we need one more point here also, and that is Lenz's law. See, this is which is comes under PU syllabus, so don't take any stress to by heart or understand and all. Just you need to concentrate. It will be very easy. Lenz is a scientist. He stated that the Lenz law is an induced current in a closed conducting loop will appear in such a direction that it opposes the change that produced it. So again he explained this law under electromagnetic induction. So let me explain what he just stated. See, we know that yesterday we have a coil and we have a magnet. And magnet has its field. When it started to approach, that is when the motion of a magnet changes, an induced current will produce in this coil. And this is what we learned in 10th syllabus. So we need to go one step ahead in a PU syllabus. And what he stated and what this Lenz stated there is that when this magnetic field start linking with this coil, what happens? There will be something that it will start oppose this magnetic field. While opposing this magnetic field, these induced current will produce. And remember what I told the word, when the induced current started to produce from this magnetic field, at end of the coil will start opposing the magnetic field, which was this magnetic field is trying to link, but at the same time it will start oppose that magnetic field. So only this much what he told, but all what you want to remember is, remember what I told, opposing. Opposing is nothing but, again we can call it as repel. See, when we heard the word repel, what comes under the property of magnet? Like poles will repel each other. So after a magnet will start produced, and when it started to repel, how it will repel? If we have a north pole here, to repel, this end should act as north pole. Understood? To repel this magnetic field from this pole, this end should act as a north. Only like poles will repel each other and opposite poles will attract each other, which we studied under properties of magnetic field. So what happens if we have south here? So again what happens? If we have south end, same thing happens. The same repel technique will use here, and repel happens only this will act as a south. This is what he stated. Now I think you understood only this part. You will study this in depth when you go to the PU level. Now just understood, no need to buy anything. Just keep in mind, when this magnet will produce from this one end and it will start to repel it back. So to repel, this end acts as a same pole. That is the second point. Okay. So in other words, we can just easily understand what the statement says is that in the induced current generated in a coil, that is here, if the induced current generated in a coil will be way that will oppose the reason which actually what it produced from, it will oppose is that it will again repel. So this is what Lenz stated. Now I hope you understood both clock rule as well as Lenz law. Now we understood both clock rule and Lenz law, right? Now look at this question again. If a south pole is approaching a coil, so just imagine or write this here. We have a coil. If a south pole, that means we have a magnet and the south pole is approaching approaching the coil. Then the direction of current at the coil end is what? That is what we need to find out. So as I told, here magnetic field will produce based on Lenz's law. What happens? The induced current will produce by repelling that magnetic field. So to repel this end of a coil, that is we have the liquid AB, we'll name this end as A and this end of B. So this end of a coil will act as which pole? This is our first question. If we have south pole here, this will act as a south pole for what? To repel, right? So hence they both act as a south pole. What is our next question? Direction of the current at the coil. And now use the clock rule. So since we have a south pole here, remember direction of the current in the coil. They are asking in the coil. So S is like this. That means it will flow like this. As we told, what is this? The current will flow in south end, that is clockwise. So hence our answer is clockwise. I hope you understood. If you not understood, watch it again and try to answer this question. Okay. Now, as I told, this is the only chapter where we will get different types of question. Now let us solve one 4 marks question under the EMI topic.
Now let us see how they will ask question under this EMI topic. The given figure shows a coil connected to a center 0 galvanometer. The galvanometer shows a deflection to the right when the north pole of powerful magnet is moved to the right as shown. What is the again read the statement. Whatever they are telling in the statement, they are given in the form of diagram also, so understand both at a time. And based on this, they asked again 4 more questions which we need to ask. Usually this is a 4 marks question. Now let us see how to solve this question.
Now we understood the question and they are given 4 sub questions. Let us see what is the answer for the first question. And first observe the diagram. What they are given? The coil A and B, they get names for the ends, which is connected to a galvanometer, and a magnet with north pole is moving towards the coil. This was the question. And obviously we know that if a north pole is approaching towards the end, the deflection in a galvanometer shows towards right. That is here we have. It's right. When it's going away or when it's withdrawn from inside to go away, then it will show towards the opposite direction, that is south. See, here they are not framed any question under this. If not, they will also frame what is the direction of the needle in the galvanometer. Then the answer will be right. So this is what the diagram. And what was the first question? Explain why the deflection occurring in galvanometer. Think what will be the answer? Why deflection shows in the galvanometer? Just one word answer. I hope you got the answer. See what happens when this magnet goes inside. So the induced current will produce. Where the induced current will produce? Only when the induced current will produce, the movement of deflection, the movement of this deflection of a needle takes place. We know that. And what was the name called for this process? The name for this process is nothing but EMI, electromagnetic induction. Hence the answer is the deflection occur in galvanometer due to electromagnetic induction. So don't write anything else, just write out what was expected. Okay, only for 1 mark this is. So this is due to electromagnetic induction. And look at the next question. Does the direction of the current in the coil appear clockwise or anti-clockwise when viewed from the end A, from this coil? See, this is question related to Lenz's law and our clockwise, the clock rule. So what they are asking, the direction of current in the coil, which side of the coil? A, at the end of A, whether it is clockwise or anti-clockwise. Now come to the diagram and observe north Pole is approaching towards the coil A, right? According to Lenz's law, what is that? When the magnetic field started to produce here, this end of a coil started to repel. So when it will started to repel, when it will act as a same pole, then it will act as a same pole, that is north. This is the first step. If A is north, we can easily find out the direction of the current, whether it is clockwise or anti-clockwise. See, if it is north, what I told in the clock rule, it will go like this. This means what? From 12 to 1, that is anti-clockwise direction. Hence the answer here is anti-clockwise. So this is what I told, they will ask indirectly. If you are able to solve this, then you can easily score marks under EMI also. Now let us solve another two questions. Next question is, state the observation in galvanometer where the coil is moved away from north pole. See, come to the diagram. What question tells us? When this coil move away from the magnet, that is from the north pole. What happens? See, this is the same scenario that when this magnet withdrawn inside and moves away, or when it moves away from the coil. But here in the question they are telling, instead of magnet, the coil will move away. See, one or the other will be moving. So then what happens? The magnetic field lines will keep reacting with different, with the distance of this coil. They will link with this coil. So then what happens? Is nothing but when they, just imagine when this magnet moves away, that situation, and what happens? It will show the deflection opposite to the direction of when it's moving towards the coil. That means it will move towards opposite direction. That is, in the galvanometer, the deflection of a needle will be left side, and that is our answer. Hope you understand for this third question also. And fourth one, state the observation in galvanometer when both the coil and magnet are moved to the right at same speed. See, here let it be a coil and this one will be our magnet. What they are telling in the question, they are moving in the same speed towards right side. See, when these both are moving with the same speed towards right, can you guess anything? Couldn't you tell that they both are in stationary? See, when they both move with the same speed, nothing will change. That means that will act as a stationary. And we know that when magnet is kept stationary, means when this magnet and the galvanometer, that is in the coil, when they come both are at stationary, what happens? What we will observe in the galvanometer? That is nothing but the galvanometer will not show any deflection. That is G is equal to 0. See, I think you understood again. When they both move in the same speed, it acts as they both are in stationary. And in the last class I told that when this magnet come and stay here, that means when this come into this coil, it will act as stationary, both magnet and coil. When they act both stationary, we won't get any deflection in the galvanometer. And this is answer for the fourth question. See, I think now you understood which type of question they will arise in EMI concept. They won't ask anything directly. If they ask directly, then you can easily score marks. For this, you need to think and analyze and you need to state your answer. And see, this is only for 1 mark question. If you write G is equal to 0 or if you write galvanometer doesn't show any deflection, then you will get 1 marks. Now I hope you understood. And under this EMI, we have one more subtopic, that is Fleming's right hand rule.
Fleming's right hand rule. Here I am not explaining much because it is almost similar to Fleming left hand rule, which I explained in detail in earlier classes. But instead of left hand, here we are taking our right hand. Other than that, the same thing here also, our thumb represent a direction of motion of a conductor. Here that is nothing but force, but instead of force you should always write here the thumb points the direction of motion of a conductor. Then forefinger is the direction of magnetic field, and one more we have, that is our middle finger. There in the left hand rule we told it shows the direction of current, but since it comes under EMI, here we need to write our forefinger shows the direction of induced current. So it's almost similar. If we know the direction of magnetic field, we should easily keep our right hand, and from right hand we can easily determine the direction of induced current. Now we finished about electromagnetic induction. See, electromagnetic induction is used in electric generators, and this is also acts as its application. If they ask what is the application of EMI, you can write it is used in generators, which we will learn in next class. And we solved one question, right, for 4 marks. The same question I given in the homework, and the similar 2 more questions I am given in the homework. Try to solve. To solve that, you need to understand the concept. Let us see how you understand, and you can evaluate yourself whether you understood this concept or not.